let's see, week 1 is 193. 191, 193. Okay, you can see the schematic. Okay, basically they count up 0 to 15, then 0. And now if you're using the loop, okay, the first one, you have to say for loop, right? For. Okay, it's talking about count up. Okay, then you're using the for loop for integer j equal 1. Okay, j less than or equal what number?
$16.
16, right?
Yes.
Okay. Greater than equal 16. J plus. Okay. That means you try to doing 16 times. Then first thing you need to open the brace for the for loop. And in here, you must be close. Just telling and for loop. Now, how many tests they supposed to do?
How many what, Mr. Pham?
How many tests we're supposed to run in this loop?
It should be from 0 to 15. It is equal to 16. 1/6 test.
That means they're going from 0 to 15 to 0.
Yeah.
16 tests. Okay. So the first thing in the loop, you have to tell the computer that number plus. That means what? We try to increment the test number. Correct?
Yes.
Otherwise, if you put a test number outside the loop, and that will be not increment. Okay? That have to be. In any loop, you have to say test number plus. Okay? The next clock, whatever you want to do, okay? You can say apply and clock or whatever inside. That means we need to apply the clock for 16 times. Every time you apply the clock, the counter will be count 1. So that's why you need inside the loop. You can say and CLK function. Okay, you want to apply clock. However, in the loop here, few things you have to understand. First thing, the expected data. If the J equal 1, you want the counter count to 1. J equal 2, you want output equal 2, and so on. So that's why you have to say expect data equal J. J1 output, you want it to be a 1. J2 output to be 2. However, if J equals 16, output not equal 16. What output equal?
0.
0. So that's why you need to using the if statement. You can say if, okay, if J, okay, greater than 1 or less than.
In this case, greater equal than 16.
Okay, less than 16, right? Then what expect data equal?
J.
J, correct. Then you say expected equal J. However, if J equals 16, output is not 16, output 0. So that's why you have to using L. Okay? And you want expect to be 0. Okay? Now, any question up to that point? If it's not, we can get another problem here. Okay, when you start counting up, the first test, if they're not counting, they can be wrong with U1 here, U2, U3 here, or whatever you hear. But after they already count to number 1, they count number 2, anything wrong will be U3 only. Then you have to use the if statement again for the peacock. I copy that one. Okay, I paste them out. Now, I can say if J equal to 1, what peacock equal okay, peacock equal. I just given you an example. They can be U1, okay, U1, U3, U4, U5, for example. That one you want to know. You have to look into part C. Okay, L, peacock equal. U3 only. Now, you can look into here. You see that? Count up to 1. Okay? Peacock equal U1, U3, U5. After that, peacock only U3. U1, U3, U5. Not U4. That's what I just telling you. By looking into the part C, you're able to coding your program. And then now we'll be reading part C or whatever. Then we'll be done.
Mr. Pham, it's probably not a big deal, but after U1, U3, U5, should those be commas, not dots?
What?
The separation between U1, U3, U5, Mr. Smith said that it could be commas instead dots.
Yeah, that's okay. Inside the double quotes, you not get error. Okay, so basically, just telling you what's going on inside the loop. Okay, inside the loop, you must get that number increment. And you need to apply whatever need to make the circuitry working. Then you have to looking for expected data. If expected data is not changing, you can put outside. Okay. If they changing very with the yeah, then that's what you need to using if statement. And also for the P corp, by looking into the port C, then you can using the if statement. Okay, in order to get exactly what they want. J equal 1, you want P corp 1, 3, 5. However, after that, else, only U3. And that will be end of the loop. Reading, port C, verify, whatever. Okay, so any question, anything? And on the left, number 10, okay, some students try to using the loop for the left number 10, you get the input timing. You run the simulation. They given you output, not much. They count up 0 to 7. Then they count down from 7 to 0. At this, if you want to using the loop, then you have to say for j equal 1. Okay? If j less than equal 7. Is it correct, Mr. Smith? Okay. You increment the test number. You apply the clock and expect data. Okay. I can give you really example here. Make sure that will be a lab number.
Number 10.
Okay. J equal 1. J less than
7.
7. The thing is they counting from 0 to 7. Equal 7. J plus plus. That number, okay. Now, expect data. J1, they count 1. J2, count 2. Okay. J7, they count 7. So you don't have to using the if statement here. And also you don't have to using the P corp here. The thing is, I believe P corp will be equal U2. Okay. Only thing is, when you're reading port C, okay, you understand the bit for port C. They will be 8, 7. Seven, 6, 5. How come they don't going down here? 6, 5, 4, 3, 2, 1. Normally, when you try to say j equal 1, j less than 7, expect equal j. That means they go with the decimal number. 1, 2, 3, 4, 5, 6, 7. However, in your program, I can think the output, for example, they will be Q3, Q2. Okay? Then that one will be Q1. And that one will be Q0. So if you want it to be a 1, 1, 1, 1, 1, 1, 1. So basically, that is not number 7 in a decimal. If you want what number, you have to using 2 power of 1, 2, 3, 4, 5, 6. Okay? That means the decimal, you can come up 2 power of 6 means
64.
64, right?
64.
64. You adding power of 5, 32. Adding power of 4, 16. So the decimal, they will be a very big number here. Adding up, they cannot be a 1. So that's why you have to using, you reading the output, and you have to shift that one. Shift the bit here. They get 4 bit, 0 here. Shift to the right 4 times. That means you moving that number, okay, into 4, 3, 2, 1. So we want to shift it, okay, to here. So now they will be a number 7, okay? And normally, you have to say expect data equal j. However, when you measure the data, you can say measure data. After you read, you can get the measure data. Okay, equal. In order to shift, how? Shift to the right. Is it that one, Mr. Smith?
What? Oh.
I asking about shift the.
Is it the other way? Wait a minute, I'm trying to find my paper. I know what you're talking about. You got to use that operator to move it 4 bits either left or right.
That means after you reading POC, they given you the major data. And that major data will be given to you in here, not in here. So that's why you have to use measure data equal measure data, shift it to the right 4 bit.
So it's not measure the first 4 bit, it's measure the second 4 bits.
That
Five.
means they're using the second 4 bit.
It would be point the other way. And
Yeah.
so your insertion operator there should be pointing the other way toward the 4.
Okay,
Yeah, that's what I was going to say. Yeah, that's right.
okay, I correct that.
That's the one that you showed me, right, Sam?
Yes.
Only thing, those insertion things should be pointed the other way.
Point toward the number 4, yes. Because it's pointing toward the measure, that means it's moving to the left. No,
No, Mr.
the
Pham,
other
the
way.
other way.
It should be pointing toward the 4.
Measure data.
Yeah, and
Yeah.
then go point toward the 4.
Yeah, you want to point those that operator thing toward the 4. No. you got it.
Is it that one?
Yes.
Like, yeah, but take that last. Yeah, there you go, right there.
Is it correct?
Yeah, that means moving to the right 4 bits.
Right. Let's shift to the right.
Mhm.
And it's start at, so that's defined as only 4 bits, not starting at 4.
That will be shift to the right 4 bit. If you want shift to the left, then that one. Opposite.
Hey, Mr. Pham, I got a question. Where you got Q0, Q1, and Q2, and then underneath those you got 3 1s, and then underneath that you got 16, 32, 64, 32, and 16. I understand you're using the formula to the end, but what to get 16 normally is 1, 2, 4, 8. So which is that?
Okay, now, if you want to see what decimal, you're using 2 power of what? 6, right?
2 power 6.
That's what you get 64. And now you want that number in decimal. 2 power of 5.
5.
You get 32. If you want that number,
2
2
power
power
of
4, you get 60. So basically, at that time, the decimal will be 64, adding 32, adding to 60. That's not like you say, expect data equal J7, expect equal 7. So that's why I said, in order to do the loop, you have to shift it 4 bit here to the right. So now after you say measure data equal measure data, okay, shift 4 bit to the right. So this number will be moved to the right here. So this is number 7. You see that?
Okay.
That's only thing. If they using the pin S765, they will be telling you. If you're using decimal, then you must be shifted to the right.
In this case, you're using 5, 6, and 7, and we're not using 8.
You still have to using 4 bit, right?
Mm-hmm.
Okay?
Okay. And okay, 5 is Q0, 6 is Q1, 7
Number
is
8 not using.
right.
Okay, so now I need to share my iPad. The thing is we need to talking about the memory. Okay, that's a very short. Okay, that will be not
Mr. Pham, just one last thing. On that last one we just completed, you said for the class, you wanted us to use the loop or you do not want us to use the loop?
Either way, but I'm doing without the loop.
Oh, okay. So you did it without the loop.
Yeah, the thing is just about 10, 11 or 12 tests, not much.
Mm-hmm. But that's a good example because it's small enough.
Yeah.
Okay, thank you.
Okay, now we're talking about memory. You understand the memory? That's a very simple thing, okay? Inside the computer. So inside the computer, basic for microcomputer. First one, if you're looking into that, you can see microprocessor. Right now we're using i7 CPU. That's a good one for now. They can using C7, C5, i7, i5, i3. Okay, before i3, they're using a dual. That's quite different. So in a computer, you get microprocessor, okay? And inside the computer, you can see they get 3 major bus. First one, address bus. You understand it, the bus, that means more than one wire. Computer we're using right now, 64, okay? 64 means they get 64 wire for address. I given you the example. If computer only 3 bit, 3 wire, then you can using 2 power of 3. Your computer get only 8 location or 8 address. And now the computer we get 64 wires address, 2 power 64. That's a very, very big number, okay? So 64 bit, that means you can see you get 64 wire, okay? In the computer, they're using parallel, not serial. So 64 bit, you get 64 wires in parallel. And they get only one go direction from the CPU coming out, not coming in. So that's why you see the arrow here, they just coming out into the bus here, 64 wire address. And now the second bus, that will be a data. And you see the data bus, they get 32 wire, okay, for the data. And they get a bi-directional. You see the arrow. They can go in, data can go into the CPU, or they can leave in CPU, bi-directional. And the last one we get here will be a control bus, not much. Also will be bi-directional. Okay, I can give you the example. If the CPU connect to the printer, okay, connect to your printer. When you click on the print to try to print something, what happened? First thing, the CPU will be sent the 1 bit that will be a control to the printer to asking for, okay, we want to print something. You understand in the binary you get either 0 or 1. Normally it can be 0, that means nothing. However, if this bit go to 1, the computer get that bit they want. They know the CPU want to print. Okay, so if your printer okay, then the printer have to send it back. The signal, tell the CPU, okay, I'm ready. Then the CPU can be let you print. That will be in the control bus, okay? Like, you know, if the CPU want to sending your data into the memory, then they have to let the memory know, I want to writing data. Or if the CPU want to reading data from memory, also CPU have to send the signal, let them know, I want to read. That will be in a control bus, okay? Now, inside the memory, first thing to get the RAM, memory, random access memory, okay? When you buy the computer, they will be asking you how much memory you want. You can say 1 gigabyte memory, or 4 or 8 gigabyte, okay? That is the RAM, random access memory. And if you see on the RAM, the data but from the CPU coming out, then we go in the RAM, or can be out of the RAM, depend on the operation. You want to write data to the RAM, or you want to read data from the RAM, okay? And before you want to read or write data into the RAM, you have to, CPU have to send which location inside the RAM. You want to read data or you want to writing data. And that's why you see that that's a thread only coming in, not coming out, only by one directional, okay? However, data will be bi-directional. Data can come in or data can be leaving, okay? Normally, when you turn on your computer, they start running Windows. So the first thing, Windows must be loading into the RAM. Okay, so they can control the computer to working with the window. And now you say, okay, I want to run PSpy. So when you click on the PSpy, they will be loading all of the data PSpy into the RAM. Let the computer working on PSpy. Anyway, anything you want to do in your computer must be loading into the RAM. Okay, so that's why sometimes the students don't know. That means they keep loading into the RAM, even they no longer using. That will be make your computer running slower. The thing is, too much data inside the RAM. Or sometimes they run in the background, like to get a virus or whatever, antivirus. They have to be loading into the RAM. However, they run in the background, do not see it. Okay, that also makes your computer slower. So when you turn off your computer, what happens? All of the memory inside the RAM will be reset to 0. And later on, you can see the flip-flop, that's the 1-bit memory, 74D. They get a 1 output Q. Okay, we're not talking about not Q. Only 1 flip-flop, they get a 1 Q. So Q, that means a 1 bit. They can be either 0 or 1. Okay? Like the RAM also, when you turn off power for your lab, everything will be turned off, 0. Okay? Now the second one, ROM. Read only memory.
Question, Mr. Pham?
Yeah.
The ROM is the same that the EEPROM?
Right. That's
Okay.
later.
Okay.
At the beginning, they're using ROM. Read only memory.
Okay.
Okay. So basically, on that one can be wrong here. Only coming out, not coming in. Okay? That will be correct later on. We'll be talking about a little more. Now I'm talking at the beginning. All of the data inside the ROM, when you turn off the power, data still there. That's what they call operating system. When you turn on the power, data from the ROM coming out, tell the computer what to do.
Oh, okay, so Mr. Pham, so just to double check, the operative system and the firmware or BIOS
That's a firmware.
Sorry?
That's just a firmware.
Okay, so operative system equal firmware.
Yeah.
Okay, okay.
That
okay.
means data cannot be lost when you turn off power.
Yeah, got it.
Okay, now I'm telling you, in the past, when you're using the computer, they're using mono display. And now you want color. Okay, you want a color display. What happened is you have to open your computer, try to set the switch for the mono to color. So they will be display color. Okay, that's at the beginning. However, how many people want to open your computer? See that? So that's why they get a problem. Then they will be changing to a different version. Okay, EEPROM or EEPROM. Okay, that means later on you don't have to open the computer. You still change the data, the firmware inside the ROM. Okay, and finally, I/O interface. That means connect to the outside. You connect to the scan, you connect to the printer, whatever you want to connect it. Okay, that's what we're talking about. I/O input, output device. Memory concept. Data stored in the memory by a process we call a writing and are retrieved from the memory by process called reading. So basically you have two processes. Writing means you write data into the memory. Reading means you get the data out of memory. Memory are made up of storage location in which data can be stored. Each location is identified by an address or location, either one, okay? The total number of bits that the memory can store is our capacity, okay? 1 byte equal 8 bits. If they don't want to using the bit, they're using the byte. However, make sure you understand 1 byte equal 8 bits. Memories are made up of storage elements. They can be using flip-flop or using capacitor or using magnetic. Normally we're using flip-flop. That's what they call us static memory. Okay, so that's why sometimes you buy the computer, they asking you to wanna add RAM or DRAM. Add RAM means static RAM using the flip-flop. DRAM, that means dynamic RAM using capacitor. Okay, a storage element is called a cell. Now you see, I'm using the simple one to make sure you understand how memory organized. This is the memory, okay? Only 4 bits, okay? And at the first thing they say address 0, okay? And they can go up to the last one, 2 power of 4. You can get 16 location. Each location here they call a cell. Okay, each cell just a 1D flip-flop, 1 output queue. So you can get 1, 2, 3, 4 flip-flop. Each one get a queue. Okay, and the first thing they say is address 0 or location 0, either way. And location 1, 2, 3, 4 up to maximum will be 16 in this case.
But
So
each bit is 1 flip-flop?
yeah, the thing is flip-flop get 1 queue. Queue can be turned on or they can be off. On means 1, off 0. So now you want to sending 1, 0, 1, 0 into this memory. So the first, that's what I call write data. So after you write, data will become 1, 0, 1, 0. Okay. So that's why when you're writing data to the memory, you must tell the computer which location, which address.
Yeah.
Otherwise, they cannot.
Yeah. Mr. Pham, could you please go one step back? So just to double check, in this case, for this example, each address is composed of 4 bits, right?
Yeah, they get 4 bits for each location.
Okay, thank you.
Okay, now, when you say on your program, can you tell me what is it? When you're working on your program, you say integer I.
Yeah. So what is the question?
What is I?
What it is?
What is I in this one?
And a variable, an address.
Very good. I will be a variable if you're talking about the program. However, if we're talking about I mean address. Okay, that's just the address. And if later on you say I equal 150, that means they take number 15 stored into location 8. Now, if you want to know what exactly location in the computer by binary, you can say cout. Cout means print, display, okay? And you can say address. And you display ampersand I. Ampersand I, that means you want to display the real location in the memory. That means they can be displayed number, whatever number 1, location 1, or location 3, either in decimal or in binary, in hexadecimal, not binary, okay? Now, when you say I want to write data into 1010 into a location 1, then after that you can get 1010. My question is, if I want to write 1100 into the same location, what happened? After I'm writing 1010 to address 1, you can see inside they get 1010. Now I say I write again data 1100 into the same location 1. What happened inside location 1?
You have to overwrite the previous number.
So tell me, after I write 1100 to location 1, what inside address number 1? Okay, I repeat. First time I write 1010 to location 1. Inside now, 1010. Next, I write 1100 to the same location. 1. What inside now?
A different number.
What number? The number now will be 1, 1,
0, 0.
0, 0. That telling you what? That means when you're writing data to the memory, or not, whatever inside that location will be deleted with the new data. You understand that?
Hey, Mr. Pham, so that's the same as like if you're on the web and you are searching for something and you enter some information and then you change and want to enter some new information, the old information is deleted and the new information is what's there. Is that how it is?
Exactly. I'll give you an example. You open the left hand. Okay, Excel, you open it. Now, after you edit something, you save to the left hand in your drive, in your USB. Then the left hand in the drive, that will be address. Okay, that means address the left hand. And when you, after you're done, you save it. And they looking for into your drive in the location, the left hand, they see something in there. So that's why they will be asking you, do you want to write over? Okay? If you want it, then you say yes, they erase. Okay? They will be drive into that location with the same variable with the different data. Okay? So that will be telling you the process write to the memory. Now, next one, read. This is a process how to read. When you want to read data from memory, you have to tell them what location, what address you want data coming. You say address number 1. So they will be get the data 1010. Take it out. That means read. So what happened at the location after you read it? When you get the data coming out.
Go ahead, Marcelo.
It doesn't change because you are only reading.
That means data still there. Nothing changed with the data after you read it. Okay? That's a process telling you writing or reading. Now, in electronic, we're testing the memory. We're loading data into the memory. Okay, I given you example. This location, I loading 0, 1, 0, 1. Okay, and the next one, 1, 0, 1, 0. Normally, that's what we do. You can understand why. In each cell, you get a flip-flop to get a queue. So they want to make sure this queue and this queue have to be a different logic. So in case they messing up, they will be failed. If you test a on 1 or on 0, you never know. Okay? The thing is, two output tie together. If they get 0, both 0. If they get 1, both 1. And you cannot know what's wrong. So that's why in binary, normally they testing 0 here, then 1 here. 0 here and 1 here. And the next one have to be opposite. That means this flip-flop and this flip-flop. This one and this one can be tied together. So that's why if I test 0 here, I have to test 1 here. Okay? And after that, you testing the first location 0, 1, 0, 1. That means the first flip-flop you test 0. Now you have to test 1. So the next data for location 0 should be 1, 0, 1, 0. Each location must be tested with 1 and 0. Okay?
And Mr. Pham, that's why you always do that little U test on most of your D labs where you're testing for 5, 5, and AA. Is that correct?
Exactly.
All right.
That means make sure 2 pins, if they tie together, they will be failed. If you test both 0, they tie together, you never know. They test both 1, they tie together, you never know. That is how the way we're testing the memory.
Mr. Pham, isn't it sometimes memory can be tested all 1s and all 0s, but that's technically not the safest way to test the memory cell or the address? You want it to be opposite 0101 versus 1111 versus 0000.
That's what I already said.
Right.
And
So,
each cell, they get a flip-flop. If you test on 0, on 1, if the flip-flop tie together, you never know.
because I've seen testing when it's not 0101, it'll be like 1101 or 0011, or it's just mixed up. They're just testing random.
Yeah, you can test basic first, then you can test random later. How do we know 2 flip-flop tie together? That's why you have to test 0 and 1. You see that? You can say, I test 3031. No, that is not the way. That's a random. Random can be tested later on after you have to test the basic. If 2 pins tie together, if you test 30, you never know. Okay? Type of semiconductor. ROM read-only memory. Non-volatile. Data can be read, not write. RAM, random access memory, both read and write operation, and a volatile memory. That means you turn off power, they erase data. So data are locked if the power is removed. The ROM family Okay, if you're reading through that, you can get from programmable, read only memory. Okay, that is a different version. When they're using a prompt before, you want to erase data in the ROM. You have to buy the tool, okay, in order to erase data, okay? And you can write a new data, okay? EEPROM, electrical programmable, ROM, electrical programmable by the user, can be erased either by exposure to ultraviolet light. That means you have to move by the tool in order to erase and program anew. Okay, last one, EEPROM, electrical erasable prompt. That means we're using right now in the computer. If you want to change something, then you have turn it on, drop, press F2 or DEL. They take you into the bio. Now you can check, okay, without any tool. Okay, RAM family, static RAM. Okay, stored element in at flip-flop, delete, okay, the flip-flop figure. Data can be stored for an indefinite period of time as long as power is on. If the power is still on, Q equal 1, they still keep 1, okay? If Q equal 0, they still be 0. However, if you remove power, Q will be 0. Okay? Dynamic RAM, data stored on the capacitor, require periodic recharging, okay, or refreshing to retain the data. That means if you're using a dynamic capacitor charge up to 5 volts, that means logic 1. Okay, go to 0, they will be logic 0. So they have to be recharged. That means they have to check to make sure capacitor still in either 5 volt or 0. In general, make sure they still be in logic 1 or logic 0. Was and by a complete unit of binary information or data, they call a word, okay? 8-bit group, we call a byte. Byte equal 8-bit. Capacitor, capacity, a way of specify how many bits can be stored in a particular memory device. In the memory, 1K represents 1024 words. Remember, not 1,000, 1024 words. And word, how many bits? How many bits for a word? Who can tell me? How many bits?
One bit?
8 bits or 1 byte equal 1 word.
So basically, how come you say 1? How come you say 8? You can tell me why you say 1 bit for word or you say 8 bit for word. Who can tell me? How many bits per word?
Because it's one one flip-flop per byte? I
No.
mean, bit?
No.
Hmm.
Okay, now, word and byte a complete unit of binary information or data. That's what they call words. I can tell you. Basically, what depend on the computer. Computer, you get 8 bits of the data. Okay, so the word will be 8 bits. If they get a 16 bit of the data, 16 wire for data, so the word will be 16. So they vary depend on the computer, okay? You cannot tell exactly number. That based on each computer. And they say 1K using in the memory, that will be representing for 1024 words. Okay, now, example. A certain semiconductor memory chip specified at 2K by 8. So the question is, how many words can be stored on this chip?
Sorry,
Me, how many words first?
What is the size of the chip? 1K?
2048.
I'm talking about an example. A certain semiconductor memory chip is specified at 2K by 8. Try to get along with the way they display for the memory.
Well,
How many words can be stored?
2K is doubled 1K, and 1K is 1024, so it's got to be 2048.
Exactly. You say 1K is 1024 words. 2K, you times 2. Okay, 2048 words. And each word will be 8 bits. That means the data will be 8 bits. Okay. How many total bits can this chip store? How many? You take 2048 words times 8. That's what you get the capacity, total bit of that memory. A thread, a number that identifies the location of a word in the memory. So that's why sometimes I said address, sometimes I said location. Okay. Read operation. A binary word stored in a specific memory location or address is sent and then transferred to another location. That's what you get the data out of the memory location. That's what they call a read operation. Write operation. A new word is placed into a particular memory location. It is also referred to as a store operation. And access time or cycle time, that will be, you can read it, okay? That's for basically for engineering, okay? Like access time, amount of time required to perform read operation. That means take how long they can read the data out of the memory. Cycle time, amount of time required for the memory to perform read or write operation, then return to its original state, ready for the next comment. Okay, now try to see on this one. Example, a certain memory had capacitor 4K by 8. First thing, how many data input-output line does it have?
8.
So now you can say you get the memory here. Okay, that will be 4K. The question is, you get the input will be a thread. Data in out. That will be data. The question is, how many lines for threads? How many wire?
10.
Okay, you say 10. Who else?
8.
I'm talking about a thread first, okay? I'm not talking about data.
12.
Okay, now
12.
you have to say, you get 4K, how many what?
For 4,096.
5 times 1, 0,
Mhm.
24. Okay, so you get
4,096.
4,096 address. Okay. So they want to know how many wires for address.
The formula is 2 to the n, and then whatever n is, it should equal 4,096. And that's the answer.
They're
That's
telling me how many
8
wires.
wire. 12
Okay.
wire.
If you get the 8 wire, I'm telling you, if you get the 8 wire, you using 2 power 8.
I'm
What
sorry, it's a 12 wire.
So basically 2 power of 60, 64, 728, 2 power of 8 is 256. So if you get the 8 wire, they go up until 256 location only.
Hey, Mr. Pham.
Yeah.
2 to the power of 12 equals 496.
Exactly. That's what I'm going to tell you.
So one of the students was right. He said 12.
Yeah. Okay, so now you have to using the formula. 2 power of n equal 4,096. And in this case, n equal 12. So that 12 address line or y. That's how to do calculation. How many
What was
wires?
the capacity? What was the capacity?
No, we're not talking about capacity yet.
Oh, okay, okay.
I'm talking about address lines.
Mm-hmm.
How to get the right number of wires go into the memory. That using the formula. 2 power of n equal 8. That means you get only 256. Okay, location. Now we're talking about data. How many wires for data?
Hey, Mr. Pham, go back and explain how you got your 256.
Okay.
8 wires.
You get 2 power of 8. 256.
Oh, okay.
Okay. That means you only up to the memory location 256 if you get only 8 wire. If you get a 12 wire, you can get up to location 4096. How do we calculate it?
Hey, Mr. Pham, and the wires is the same that address line, right?
Yeah, address line. How many lines for data? That means how many wires for the data in this case?
4,000.
No, 4096 is a location.
So 12.
That will be it. You see, 4K by 8. That means its location will be 8 bit. Okay, now, if I get a memory RAM, 1K by 1. How many lines, how many wires for the memory?
One.
How many wires for a thread of the RAM 1K by 1?
10 wires.
Exactly. 10 wires. 1K means 1024 location. And 1024 will be the same 10 power of 2 power of 10. Sorry. So you need 10 wire for 1K memory. How many wire for the data? How many?
1024.
I said the data for 1K by 1.
For the data, 1024.
Get my question, Nate. How many wire for the data line?
So if it's 1K by 1, is it 2 to the power of 1?
You don't have to using any power. This is telling you.
So which would be 2?
1.
1.
1K by 1. That means they get only 1 thread, 1 line of data. 4K by 8. That means they get 8 wire for the data. When you're reading the symbol here, for the memory, you have to understand how many thread, how many data lines. Okay, so number A, number B. Now, last one, capacity. Who tell me capacity for this example? What's the capacity for this one? 4K by 8.
32K.
4K, we already know, thank you before.
32K. Okay.
32, yeah.
Okay, and the data. Now they want capacity, telling me what the capacity for that memory in byte, not in bit. Okay, so you know they get a total 4,096 location, and each location will be 8 bit. Okay, the fourth location, okay, will be 0, 0, 0, 4 bit. Okay, 8 bit. The next location, same 8 bit.
1.
However, this location 0, this location 1, next will be location 2.
Or the 512?
Okay, I'm just talking about 4096 location. Each location 8 bit. 1, 2, 3, 4, 5, 6, 7, 8. And the first one I say location 0. The next location 1. They can contain anything inside, we don't care. The next location 3. Telling me last location
512?
Come on.
Well, you said wait a minute, 4096 divided by 8.
No, no.
256.
The first address, we're using decimal, I said location 0.
Location 0.
The second one, location 1.
1.
Next one, 2, 3, 4, 5. My question is, the last location.
Okay, 2 to the n minus 1.
255.
Perfect. The last one will be 4096 minus 1. 2495. The thing is you start from 0. So that's why the decimal number on the time will be less than the location by 1.
Hey, Mr. Pham, so what was I wrong when I said the formula was 2 to the n minus 1?
2 to the n
minus 1.
Minus 1. What n equal?
It's the number of, I forget what you call it.
When we say 2 to the power of n minus 1, that means we try to find out the difference between binary and decimal.
Right.
If you want to see the decimal, you have to using binary, minus 1 to the power of n. Right now, you said you get 4,096 location. That's what we're talking about, location in the binary. However, if you want to using the decimal will be less than 1. That means you get only 4095. The thing is you start from 0. Okay, what the capacitor in byte? How many bytes?
256.
How come you get 256 on this example?
Because I divide the 4,000.
No, not divide anything. Basically, they get a 4,096 location.
Yeah.
Each location will be how many bits?
Each location is 8 bits.
8 bits. That means a byte.
Yeah.
Right.
So the answer for number B will be 4,096 bytes. However, that's what the answer for number C, okay? In byte. So basically, the answer will be 4,096. If they are asking same thing, what is capacitor in bit? How can we know?
Plus 8.
Times 8. Times 8.
Times 8, okay. Okay, so this one, we don't care on the timing here. The thing is, if you're engineering, when they design, they have to pay attention. And this will be EEPROM. They can see the data and they get the address. Okay? We're talking about EEPROM, we're not talking about EEPROM. Only the different name. If you want to writing data into EEPROM, you can have to get the power 25 volt. When you press the DEL or F2 to go into the setup BIOS, that's what they have to supply a certain voltage, so you're able to write the data into the EEPROM or EEPROM. Okay, so basically that will be done with the memory. Now, when we're testing the memory, normally we're loading data into the memory. And later on, you're reading at that memory and verify, make sure the data you wrote it in and you read it out have to be the same. Okay? Anything I given to you in the DLab 11, that's the way engineering do it. How to test the memory. Okay? I just given you the example. If I get the memory, okay, address here, 8-bit. And the data here. But if you get an 8-bit of the memory, how many locations?
$256.
Exactly, 2 power of 8. That means in this memory, you get 256 locations. If you go from 0, then they be 255, right?
Right.
Okay. And each location will be 8-bit. So normally, first thing I say, I write 0101. Okay. 0101. Joe. Address. 10, 10, 10, 10. That means 0855. 08 AA. Okay. However, after I write 55 to location AA, I'm not reading right away. Okay? The way to testing the memory, you need to loading data into the memory and later on you can read it out. Not try to write and read right away. So that's why on this test, I try again. Now, 10, 10, 10, 08 AA. 2, 08 55. That means I'm doing right 2 times. Then now I start reading location 0855. Then I can reading data from location 08AA. So more people confusing. How come I using 55AA all the time? I can explain to you. 1, 2, 3, 4, 5, 6, 7, 8. 8 wire. So the first thing I want, 0, 1, 0, 1, 0, 1, 0, 1. That makes sure this wire and the neck cannot be tied together. If they tie together, they fail. And later on, I set 1, 0, 1, 0, 1, 0, 1, 0. Make sure 2 wires cannot be messing up. And each wire in or out must be tested with logic 0 and 1. If you're testing only with 0, okay, if this line connect to the route, you never know. So that's why you have to test a 0, then you have to test for 1. If they connect to the route, they will be failed. That is the technique for testing memory. So when you're reading on the DLAP 11, then do not surprise when you can see the way we test it. Okay? Next meeting, I will be talking about an array that in C++. I will be talking about the function in C++. Then I can go to the D lab 11. Try to helping you. Okay, how can we do? If the people reading over and over on that lab, that will be very simple. I given you almost everything you need. Only thing is you know how to organize.
Hey, Mr. Pham, quick question.
Yeah.
So on, like the labs in the past, you want us to pull up the Excel, do the Excel, and then after we do the Excel, write the program first or wire the circuit?
Either way.
No, Mr. Pham, make it one or the other so we can be consistent.
Okay, you can get your program first.
Okay. So get the Excel, make the Excel pass, and then write the program.
Right.
Okay.
But the Excel on this time, very simple. Not deal with port A, B, C. Port A, B, C, D, just a reference. Okay. However, I get a one with the scattered part of hell. Try to get that part first. Okay. And next week, I can go through it and try to explain to you. First thing, how the circuitry working. Second thing, how do we test the circuit? If you're reading the handout, all of the thing I'm doing up there will be using the function. Okay?
Okay. So basically I got it now. So we get the Excel, make it pass, write the program, send it to Sam. He'll test it and see if the program's any good. And if it's not, he'll send it back.
Right. Hello, Sam.
Hello, Mr. Pham.
Do you have a circuitry for this memory lab? If you don't, I can give it to you one.
Yeah, I do have it.
Oh, okay.
Yeah.
So you really working very good.
Yeah, I've been keeping up with the class as we go.
Okay.
I agree, Sam, but staying up all night doing a good job.
Nobody can do better, build a circuitry better than him.
I know. He does a good job of staying up all night doing this.
Only thing, be patient. That's it.
Okay.
Okay, so any questions to me?
Sam.
Yeah, I have question, Mr. Pham.
Go ahead.
Can we review again the answer for the 3 questions about the 4K times 8? The memory, a certain memory has a capacity of 4K times 8. So for the answer A,
4K by 8, right?
yes.
He's talking about those 3 questions that you had, A, B, and C.
Yeah, I know. Here.
Yeah, for the answer for question A, that the input outputs, how many input outputs line does it have? So I didn't write down that answer.
Input will be
Input output line.
12. 12 line. 12 wire.
Okay, and for the answer B also is 12?
How many are that line? That will be 12.
Okay, the capacity in bytes, 4096, right?
Right. How many data? They will be 8. A will be 8. B will be 12. C will be 4096.
Okay, thank you.
You're welcome. Try to understand. That's not much thing, okay?
Thank you.
That's a very, very easy with the memory. The thing is we cannot do anything inside the memory. And you get only 2 process. write data to the memory and read it out. And then, like in your room, your house, you get the room, different room, which one will be contain what inside, okay? So that will be easy for take it out or put it in, okay? So any question to me? If it's not, okay, we'll see you next week. And good night, everyone.
Good night,
Good
everyone.
night.
Thank you, Mr. Pham. Good night.
You're welcome. Good night.
Good night.